Hello everyone, and thank you for joining today's webinar on tokenization, the ultimate defense in cybersecurity. My name is Thomas Stößer. I'm the head of marketing at Comforte, and I'm your host for today. So today you will learn about the benefits and the best approaches behind tokenization to enable the best-in-class cybersecurity and data protection that is possible. Today's presenters for you are Henning Horst, Global Director of R&D, and Jonathan DeVoe, a marketing manager at Comforte. So please join me in welcoming Jonathan DeVoe.
Thank you, Thomas. So first, we wanted to start off by covering the main drivers many organizations face when it comes to data protection. Data breaches are a hot issue, and it seems that there's always something in the news about another company's data getting breached. But companies are looking at mitigating risks and costs associated with data breaches. Typically, for example, they're looking at technology to minimize the risk of sensitive data getting exposed, especially when it's in transit, like data between systems, or when data is at rest, typically stored in files and databases. Organizations just basically want to avoid becoming a news headline and then having to scramble to respond and fix the security issue. Compliance and regulations are also a major driver for data protection. New regulations that are going into effect within the next few months are projected to have a huge impact on security programs. For example, PCI DSS, the Payments Council, has a Security Standards Council, but PCI DSS 3.2, which is mainly regulations for security for payments companies, there's 12 control areas, and it's shifting from best practices to requirements on February 1st, 2018. So it's really close. It's unclear how many companies are going to be fully compliant by this date, but the PCI organization will tell you that of all of the companies that declared a data breach containing payment cards in the past, 0% of them were PCI compliant. So meeting these requirements are going to become very important. Another regulation known as GDPR, which is the General Data Protection Regulation, it's sponsored by the European Union. This regulation is meant to protect the data privacy of European citizens, but it also affects organizations who process data from European citizens, which is basically any company outside of the European Union. This regulation has been drawing a lot of attention because of the potential fines for non-compliance, which can be imposed, and you're looking at probably up to 4% of the annual revenue of the non-compliant organization. Also, as new regulations become active, some auditors are changing their interpretations of compliance guidelines, which result in a few cases which were considered compensating controls in the past. Maybe they were good enough to pass an audit a year ago, and they're no longer being accepted. Another driver is the need to maintain security while companies innovate. Modern application architectures are way more complex than previous approaches and increase the attack surface. How is the data protected as more of the data goes from on-premise to off-premise, like to the cloud, for example? How is the data protected when it's sent to big data such as Hadoops for analytics? Or how is it protected, for example, in a payments environment when it's sent off to a fraud environment for analytics? Also, it can also be determined that it's a business differentiator if your business can offer security to your customers. We have a use case example of a national retailer working with a payments processor, and this retailer told the payments processor, if they cannot if they cannot reduce their security scope by passing security tokens, for example, instead of passing in the clear credit card and debit card numbers, they're going to have to go to another payments provider. Do you have similar cases in your line of business where you might have to turn down business if you're not able to secure your environment? What about opening up your organization to new business partners? For example, open APIs from other directives. In Europe, there's a regulation called PSD2, which is a revised payment service directive. And this is going to open up automatic programmatic interfaces and allow organizations to connect with each other. Does this increase the risk of your organization from a security perspective? And then finally, costs and cost reductions are also a key driver. Finding solutions that fit within an organization's budget as well as meeting their enterprise security strategy can be a challenge. And then additional costs organizations consider are resource costs required to integrate and maintain the data security, as well as to ensure compliance is met. So when we take a look at data breaches in general, how bad can it actually be? Well, the Juniper did some research on this, and they did an analysis of the future of cybercrime and security for the next 5 years. And the situation may not be getting better. If you take a look at the chart on the left, in 2017, there were over 7,500 criminal data breaches worldwide, and most of them occurred in North America. If you look at the chart on the right, this explains the overall costs to an organization. And when it's all total, there were over $600 billion annually in costs that organizations faced in total when data was breached. The projections for the next 5 years show an increase in the number of data breaches, potentially reaching worldwide over 18,000 breaches annually by the year 2022. And when you look at that from a total overall cost perspective, that's over $2.5 trillion within the next 5 years. And also, Gartner took a deeper look at data protection, and their recommendation is data-centric security is key. They go on to say in this article, data is a pervasive, critical asset that crosses traditional silo boundaries on premises and in public clouds. This requires a data-centric strategy that prioritizes datasets and mitigates evolving business risks such as regulatory compliance and threats from hacking, fraud, and ransomware. So this is where we believe tokenization is the key technology to implement data-centric security. So what I'd like to do now is turn this over to Henning, and he's going to go through this a little bit more. He's going to talk a little bit about security tokenization and then run through a couple of use cases as well.
Thanks a lot, Jonathan. So yeah, I would like to start out with briefly touching on the concept of security tokenization itself. And for those of you who already are familiar with the topic, please bear with me. I just want to make sure that everyone has the right background so that we can drill down deeper in a minute. So basically, the concept of tokenization and security tokenization in particular is to replace a sensitive value with a surrogate, which then removes the sensitivity of the original underlying value. And those sensitive values can basically be of any type. So a typical example is a credit card number, but can also be names or date of birth, account numbers, social security numbers, etc. And the concept is pretty simple. So you have that sensitive data element, you send it to a tokenization engine, and that tokenization engine responds with a corresponding token. So the token being the non-sensitive data element produced by various mechanisms possible to produce that token from the pen. So that's the one thing. So there's for the tokenization operation itself, there are various ways of doing that, and then there's also various ways the target format of the token can look like. So the first nice thing and key differentiator to classic encryption with tokenization is that you preserve the length of the data element, which makes it possible to easily stick it into existing fixed size fields that you might have in message formats or databases. and it doesn't increase the size like classic encryption is. The second one is that as for the format, you can preserve certain digits or elements more broadly and generically speaking in the original data element. So for instance, in the case of a credit card number, you can preserve the first 6 and last 4, and you can still do some business logic on that tokenized value and don't have to expose the actual underlying value to those systems that can do their job based on that token and still be secure in that way. And PCI typical guidance is that 664 format, so preserving the first 6 digits and the last 4 digits, and a lot of business activity can still be done with that. And that means systems, or a lot of systems, don't need the actual full clear text value anymore to do their processing. If we look at then sample use cases for tokenization, and that's where what we've been seeing recently, and quite a growing number of those cases, is securing big data and what we call MOOS, standing for merging out of scope. These are just 2 sample use cases I would like to go through in a bit more detail. There are various applications and ways you can utilize tokenization to secure various parts of the enterprise, as well as the whole enterprise with all its parts. And I would like to focus on those 2 use cases that we've been seeing more recently with quite some interest in. So let's look at the first one, securing big data as well as big data as a service environments. So, and for this, I would like to talk a bit about one environment that we worked in with a client of ours, which is in the payment space as well. And what they are doing is 2 things with their fraud detection system. One is they, as you would expect, use that for their own purposes. And 2, they are using this to basically sell it as a service to their clients. So they offer this fraud management system as a service. And what's happening is that if you look at the bottom half of the slides, the clients of that financial institution, they have their regular transaction processing, which ends up at the transaction front-end servers, and goes its way through the regular transaction processing chain, with the split then from these transaction front-end servers to the fraud management system, which, and part of that message that goes to the fraud management system to do its job is basically the credit card number, the primary account number. And so the fraud management system is, as you can imagine, full of those sensitive data elements, the credit card numbers, as well as other pieces of information for the fraud management system. The clients of the financial institution can then use another set of servers, the web front-end servers, to basically configure rules for the fraud management system and optimize on that rules. They can run some sample rules and stage them against the fraud management system in a test-only mode, so that they can see, okay, had I activated this rule, how many transactions would have been rejected, etc. So there's plenty of possibility there to then configure and test against that fraud management system. Now, if you look at this, of course, you see immediately this fraud management system is a huge huge storage of sensitive data elements that are of interest to the potential attackers. And if you look closer, actually, if you think about it, what a lot of the fraud management is doing, it actually is looking for, okay, is that, for instance, is that transaction coming from the same card, and it was the customer was showing the card and having the card really with him and being in 2 different locations at the same time that are geographically not possible within that time. So that's a typical use case where actually, if you look at it, you don't need the actual card number as long as you are sure that's the same card. And that's what's typically being called referential integrity. And this is where tokenization can really help reduce the scope and increase the security of that client. And that's what we did. So instead of now sending the sensitive data elements, the PAN, the primary account numbers, to that fraud management system, we exchanged that with sending tokens, and those tokens ended up then in the fraud management systems, and on its way out to the web front-end servers, they got detokenized, so basically that the fraud management system operates completely on tokens meanwhile. So the whole exposure there is being done, and all of the fraud management activity could be done based on these tokens and based on the fact, which I just explained earlier, that the tokenization operation preserves the referential integrity to the original data element, meaning you can still see is this the same card, but you cannot see the actual card number underlying to that. Going forward, the next step there is what they look at is to move to a Hadoop-based fraud and risk management solution. And as you can see, this is just a different technology underlying this whole thing, but it doesn't change anything in the design and the fact that huge amounts of risk and exposure, as well as the security compensations that have to go with that, was removed and can be removed and just being used tokens instead of the original data element. If we look at the next case that we've been seeing more recently and increasing interest in is what we coined as a merchant out of scope use case. So let's look at what this entails. So if we look at a typical payment chain, and this is for the ones deep into the financial tech, excuse the simplified representation, but basically the merchant where you swipe your card or push your card, that sends a message to the payment gateway, which then sends it further to the networks and issuers for authorization. The message comes back for authorization, and from the payment gateway, it's flowing to the merchant then, who then stores the transaction log, which includes the sensitive data element, in this case, the primary account number, in their databases. And how can tokenization help here? So what we've been seeing, and advance to the next slide, Jonathan, please, is people implementing tokenization solutions at the payment gateway, and this was what Jonathan outlined earlier in this session, as responding to the need of reducing your client's security footprint. They were pushed to implement a tokenization solution that now, instead of delivering the PAN, the primary account number, the sensitive data element back to the merchant, to deliver a security token instead. And then, as a result of delivering the security token instead, the merchant actually only stores tokens in their settlement logs, and they can settle against the payment gateway easily based on tokens, and the payment gateway can detokenize when they need to, because they were the originators of that token. So, as Jonathan outlined earlier, in this case, this can be on the one hand, really a business differentiator in the sense of a value add that you can sell your clients, as well as can also be really a driver to be able to secure a business with your clients if they're already at the point, and we've seen that more and more, that they really ask for helping to reduce their security footprint. Of course, if we look at this in a more cloud-driven environment, this can also be run as a tokenization as a service, where the tokenization cloud sits between the merchant and the payment gateway, not at the payment gateway, to sit in that middle and hand out the token to the merchant. Okay, if we then look at important considerations when implementing a tokenization system, of course, what some people tend to overlook from my experience and from various discussions is that not only the systems that need protection in your enterprise are mission critical to the business, but really if you implement something like a tokenization solution, which is, as discussed, really helping you to reduce your footprint of exposure and increase your security. But it must not be overlooked, of course, that this system now really, the tokenization system or security system, now becomes a mission critical system to your business as well. And we had some discussions in the past with some other prospects having some existing tokenization solution where they ended up, okay, it worked in the beginning, but they had an outage of that tokenization solution, and they realized very quickly they couldn't process any transactions anymore because, well, that was so deep inside their core business that without that system, they basically couldn't do any business anymore. So it's really, of course, important to treat that tokenization system as a mission-critical system for your business as well. And what we're looking for is, of course, extremely high availability, basically being always on, being able to scale with your business, being able to have 100% reliability, come with appropriate security, of course, because that's what it's all about. And then also be able to easily integrate that enterprise tokenization system and make sure that it's built and designed in a way that is fault tolerant and can cope with the performance needs that you have in your business now as well as in the future. And all of that, of course, preferably while keeping the effort to implement and to manage that system for the consumers of those services low. So with that, I'm handing over to Jonathan.
Yep, perfect. Thank you, Henning. Yeah, and that's really key. What you were saying about mission critical is the key point, because from Comforte, this is where our background is from. We have software development that started on systems that never stop, these mission critical systems. And we've been doing this since 1998, and Comforte has been helping enterprises with security, with connectivity, with overall management of mission critical systems, for example, the HPE nonstop systems. And this results in us providing, and Comforte providing, leading security and middleware solutions. Since 1998, we've acquired over 500 customers, even customers that use the smallest or a single product that we have, all the way to our enterprise solutions. We have over 500 customers. We've participated with over 1,000 successful projects. So we have a lot of experience in this environment where mission critical is a key component to many companies. we have a global reach, so with companies that want to talk to us about data protection, we'll typically have teams that are in the region, so you're not going to have to always go back to one central point. We have people that can help out in different regions. We're privately held, so we're a smaller company with right around 100 or so employees, and that makes us more agile to be able to continue our development in mission critical systems and being, working on systems and doing software development where what Henning just said are key components to, to data protection. And it also shows in our Net Promoter Score. When our service department, our support department goes and asks our customers the likelihood of, them to recommend our solutions, we get a really good Net Promoter Score that they would recommend our solutions to other businesses in their environment. So taking from that is looking, well, where is Comforte headed? And Henning touched on this a little bit, where we focused on mission critical data protection and some of the other things we do in middleware. And now we're taking what we learned since 1998 in data protection and in security and taking that and taking the key components of mission critical over to the enterprise for data protection and in the payment space. So with that, this is where Henning is going to tell us a little bit more about how Comforte can help. We have a tokenization solution that can help your organization, and Henning can explain a little bit more about the key architecture and core components and how our solution can help your environment. So I'll turn it back over to Henning to finish up with this presentation.
Thank you very much, Jonathan. All right, yes, so the tokenization and encryption solution that we provide is called Secure DPS for Data Protection Suite. And it's basically a cluster of, a virtual protection cluster consisting of 3 key elements. And you see the graphic on the left, and I go through each of the components here. So first of all, the bluish boxes, EA, that's designating the enterprise applications that want to use the tokenization encryption services. And the pieces in green, that's really the components of the Secure DPS solution. So on the left, you see the MC, that's the management console, which is responsible for initializing the cluster, holding all the configurations, the secrets, the tokenization secrets that are being used. And the management console then, upon startup, can initialize the protection nodes. The protection nodes are completely stateless in the sense that they don't store any secrets, they don't store any configuration, and they don't have any permanent storage at all. Instead, they are initialized by the management console and then get their secrets and configurations seeded up. And after this initial startup, everything can happen just in CPU and memory in those protection nodes. And as the tokenization scheme is a stateless one, I'll talk a bit more about this in a few minutes. This is a scheme which is really linearly scalable, so you can add as many protection nodes as you want, as close to the application as you want. So latency is not an issue, and as you see, the protection nodes cluster, that's internally also communicating in the sense of, and for the purpose of being able to reinitialize protection nodes should one be down for a reason or another. So while the management console is really the dedicated point of initializing the cluster, it's sufficient actually if the management console initializes a few protection nodes, and then from there the protection nodes can actually initialize themselves with the help of existing protection nodes. So that means the cluster is somewhat self-healing and doesn't need the management console after the initial, let's say, seeding of the cluster. Why would you do that? And what's the benefit for that? Actually, the interesting piece here is that, of course, the secrets on the management console have to be properly guarded and are via split knowledge, dual control mechanisms, support for HSN devices, etc. But what you don't want, of course, is to have to go through kind of ask multiple people to enter their passwords when one protection node is going down, as well as you want to try to reduce your footprint of risk and not have the management console up all the time. So what this allows you, the fact that the protection nodes can initialize each other once one or two are initialized, is to really even take the management console down and only use it when you change a configuration, want to reinitialize the cluster with a new configuration, for example. But other than that, it's really reducing the footprint and able to reduce that with that self-management capability of the cluster. What we didn't talk about yet is the component on the right in green, the AC. That's the audit console. So of course, the solution also produces audit logs. So who requested the tokenizations, how many tokenizations, etc., etc. And those are getting logged to the audit console then. Okay, so if we look, how can you actually integrate that tokenization into your enterprise application? There are two ways of doing that. The one is via transparent integration. The other one is using what we call the smart API. Let's start with the first one, the transparent integration. And that's the typical use case for that is if you have a application where you don't have the source code for instance, and typically those are use cases at the edge. When you, for instance, need to send out data to a business partner that doesn't have the same protection solution like you have, for instance. Of course, you have to send those data in the clear to that entity or encrypted by PGP or whatever. But basically, you have to detokenize your data before you send it out. And many solutions around do this by just asking you to, okay, well, create an intermediate file in the clear on your systems and then ship it out via your standard FTP mechanisms on Linux or Windows FTP servers. Now, this transparent integration allows you to do this in a way that you don't need that intermediate file, which obviously defies the whole purpose for you to protect your data when you then start creating intermediate files in the clear. And the way this then works is that for instance, a file transfer outwards will be combined with components that allow to integrate this protection layer without actually changing that, in this case, file transfer application. And in that way, you don't have to have this intermediate file. The detokenization happens on the fly, and what's ending up in your business partners and is the data in the clear. What you always have on your file systems is the tokenized data. So no security gap there. So that's, as mentioned, a typical use case for batch type applications or file transfer applications. But of course, we also provide a API integration, Java and .NET in particular. And I would like to take a quick look on the smart API, why this is a smart API and what's the specialty of this API. So that gets a bit back to where we come from and what we see really in this mission criticality of tokenization or enterprise tokenization and protection systems is really not just it has to work, but it has to be easy to make it really always available and really comply and provide this mission criticality that is required by such a solution. And what we do with the Smart API is really encapsulating all the functionalities that you would have to implement otherwise in standard APIs, in simple APIs that are around what happens in case of error. If the tokenization, if you don't have access to that particular tokenization service node. And what we do in the Smart API is we encapsulated and implemented all that for you, that it's basically completely transparent to the enterprise application if a protection node fails or if there are additional protection nodes that you want to bring up. That's completely transparent. They will be automatically integrated into the cluster, and the load will be distributed amongst all of those protection nodes. So there's this automatic failover, load balancing, redistribution, and there's also features of ensuring that the integrity of the cluster is not compromised in the sense of, for instance, a node not handing out the correct tokenization results. So there's a periodic check for against all the other protection nodes, that all nodes are in sync and producing the same results for a certain tokenization operation. And with all of this, you can really easily scale the solution. And as outlined earlier, based on the design of the tokenization algorithm that we use, that's really a linear scalability that we can exploit here. And as mentioned, that's all transparent to the enterprise app. Of course, as mentioned, there's also auditing capability and a corresponding dashboard where you can see all sorts of information from the amount of tokenizations, detokenizations, how many unique data elements were protected, alerts, etc. And one of the things that often comes up is, of course, performance. We really come from a background where it's about online transaction processing, so performance is key. And this is what we also took forward with this Security PS Enterprise solution, is really designing it for extremely high performance, starting from the communication protocol between the components, but also resulting from the design of this protection node cluster. You can really put protection nodes very close to the enterprise application. You can put as many protection nodes as you want and as close as you want to the enterprise application. So you get an extreme low latency, very high performance resulting from that. And we just, from running this on a small scale server in our labs, we easily could perform over 100,000 tokenizations per second. And as said, this is really a small lab server, so this can scale really nicely. And then apart from the overall design for the scalability, there's of course the Tokenization Engine that allows for this scalability based on being stateless, or what some people call vaultless tokenization. And what this means is basically that you don't store any state, like in a tokenization scheme where you have a database, for instance, that stores a mapping between the sensitive data element and the token. We don't do this. This is, nowadays, this is really not an approach that's, that you should take the all the real tokenization solution vendors have realized a database-driven solution that comes with various limitations, like scalability. You need to synchronize over multiple nodes. You always have this I/O to the database. You have issues with collisions, etc. So the result of that was basically the state that you don't want a stateful but a stateless tokenization scheme. So how do we do this? It's basically based on the combination of a tokenization algorithm and a static, and it's important, a static table of, and this is a large table of random numbers, basically. And the tokenization algorithm operates on that tokenization table or tokenization secret in order to generate the tokens from the sensitive data elements you put in, respectively vice versa, detokenize the tokens to their original data element that was underlying there. And based on the design of the algorithm, that's a two-way deterministic algorithm that you really get, you always get the same token for a given sensitive data element, as long as you have the same tokenization secret. So what you do is spread that secret over all hosts, over all protection nodes involved, and then they will always produce the same results no matter which protection nodes is being hit by that particular transaction. And this is nothing that we keep kind of in our back room, but the algorithm has been validated by independent cryptologists, and due to its design, it's linearly scalable. There's no collisions because of this two-way deterministic property. It's patented technology, and it's based on an unbalanced Feistel network, and it supports various element formats to be tokenized for PHI, PII, etc. And this is actually, we hand out the token algorithm to prospects and clients to look through that. Actually, you can, since this August, also look into this tokenization algorithm, because it's one of the reference algorithms for static table-driven tokenization in the new NCX 9119 Part 2 tokenization standard. I was one of the few co-editors of that standard, and you can look into that and see that algorithm, because as it should be, the security of the scheme doesn't depend on keeping the tokenization algorithm secure, but instead, of course, keeping that tokenization secret, in our case, that static table, secure. So if we look at the SecurityPS enterprise deployment options, basically it comes down to whatever you want. You can deploy it in a classic on-prem solution where you have an on-premise app, the protection node clusters locally, the audit console and the management console locally. But you can also deploy it in a hybrid fashion. So if you have a cloud app that's running for you, you can deploy the protection nodes in your public cloud. And the nice thing there is, as noted earlier in the presentation, the protection nodes actually don't store any secret permanently, but they would always be fed from the management console for initialization, and once they fall down, all the sensitive data is gone. Another way is really of this to have the management console and the audit console in a cloud environment, and then have your app either in the cloud or on premise. And there's another tweak figuratively here in there, because now you might say, okay, you have the SecurityPS cloud, and that holds that tokenization table now in the cloud. But we provide a additional capability to randomize the tokenization operation with the help of a tweak so a additional value that the application can put in, so that only with that tweak the actual detokenization can happen. That means even though the tokenization secret is stored in the cloud, should anyone ever steal that from there, they will not be able to detokenize the sensitive data without also breaking into your other environment and getting to the tweak. And if we do this one step further, actually, while in the prior scenario, the good thing was, okay, you don't have any primary account numbers or sensitive data elements going to the cloud. In the next extended environment, we also offer the possibility to use what's typically being called as a CASB, a Cloud Access Security Broker, for the logging, so that when you run the audit console in the cloud, you don't have to be concerned that IP addresses, usernames, application IDs get to the cloud, but basically only tokens will. So the audits will also be tokenized and going tokenized to the cloud. And what then happens is with using the SecurityPS lock Cloud Access Security Broker, that will detokenize the values on the fly so that you can see the clear text values of all of those user properties or application properties, while in the cloud there will be only the tokenized values. And as you then can see, there's really zero knowledge, what we would call zero knowledge tokenization here. So there's no sensitive data that can be exploited without the need of additional data from your environment. And as you might already see, that's one of the directions we will, as a company, also move into, to provide not only the various deployment options that you just saw for your consideration, however you want to deploy this, but also offer this later this year as a tokenization as a service solution, where we would typically run this in exactly this scenario, and while you see not know any of your sensitive data. To conclude, if we switch to the next slide, yes, handing over back to Jonathan.
Yeah, thank you, Henning. Sorry about that logistical error there. Yeah, but hopefully, everybody watching this presentation and listening to Henning describe the different options that we have available with Secure DPS Enterprise, hopefully you can also see that tokenization is a key technology when it comes to data protection. And if data is the basis of your organization for your growth, securing your growth with tokenization could be and should be a key technology that you look at for data protection. With Secure DPS Enterprise, there's a couple of things I want to wrap up with and say, we hopefully you saw that there's a huge focus around mission critical and making sure that your data protection is available just like your application. It doesn't make sense if your application's running, but the security, your data protection isn't. So it leaves your organization exposed to having data that's sensitive data that's not protected. So, coming from our background at Comforte and working on mission critical systems, we've been able to successfully extend tokenization to the enterprise. And, that's a core competency of Secure DPS Enterprise. Also, hopefully you saw many deployment options. So it's not just, one configuration. You have many different ways that you can deploy Secure DPS, as well as different integration considerations. Transparency has been a key requirement that many of our customers want and need, but they also want to have the flexibility of the smart API that Henning mentioned. And again, those are core components available with Secure DPS Enterprise. And as Henning mentioned, with Secure DPS Enterprise, it's coming really soon. So the release is, we're targeting release 1.0 at the end of January. So stay tuned and listen for and look for updates from us regarding Secure DPS Enterprise 1.0. And the location where you can find more information is on our website at this link below. comforte.com/data protection is a link for Secure DPS. And also, particular to this presentation, if you have some questions for me, but I'm sure it's mostly for Henning, you see our email address is there. So feel free to send us a couple of questions. I'm going to turn it back over to Thomas now to double check with him to see if what kind of questions we may have regarding some of the topics we discussed. Thomas?
Excellent, thanks JD, and also thank you to Henning for delivering this wonderful presentation. So yeah, there are indeed a few questions lined up in the questions panel already. So before I go into those, so if you, esteemed audience, have any more questions that you would like to ask the presenters right now, please use the questions panel of the GoToWebinar interface. As JD pointed out, if something comes to your mind only after this webinar, feel free to send them an email to the email addresses that you see on this slide here. Also, one very generic question that always comes up is this webinar being recorded? And will I receive a copy of that recording or a link to the recording so I can share it with some of my colleagues in my organization? Yes, absolutely. It is being recorded, and we will send out the link to the recording in the next couple of days. So let me take a look at the questions that I see in the panel right now, and I think you're absolutely right, JD. They're more for Henning than for you, I guess. So the first one is about the data types that we support. If we're specifically tied to the PAN data type, Henning, is that something that you can answer?
Mm-hmm. Sure. Yeah. So we are not tied to any particular data type. So we can support the various data types that you would find in PII or PHI information. So names, date of birth, social security numbers, whatever. So expiry dates. While the credit card number PAN is a typical case that we see, especially in financial institutions, of course, there might be other use cases. For instance, for another client in the insurance industry, we do a lot of PII protection for names and date of birth, etc.
Perfect, thanks, Henning. And I think that sort of ties in with some of the latest breaches we've seen in the last few months, right? Where actually it was driver's licenses and social security numbers, apart from credit card numbers, that were sort of targeted by hackers. Okay. I have a second question here, and I believe it's again back to you, Henning, which is around format preserving encryption versus tokenization. Really, the question is format preserving encryption versus tokenization ? So I guess it's a pretty open question. Can you comment a little bit on that?
Yeah, I mean, this is a typical a question and confusion that I see a lot in discussions with people, where there's some, I would say, a lot of information around in the internet and in various materials that you can read up on for tokenization / format preserving encryption. And really, I think the ANSI standard gives a really good description of those, and I think that's a appropriate way of representing it. And the way that I see it, and as it's also in that ANSI tokenization standard described there, is basically tokenization is the main thing that you want to do, and you can do it in in different ways. And one of the ways is by using formal preserving encryption. And so basically meaning formal preserving encryption is a form of tokenization. So tokenization being really the act of replacing a sensitive data element with a non-sensitive surrogate value that typically has the same length and shares some other properties of the original data element. But yeah, formal preserving encryption being one way of doing this, static table-driven tokenization, as the standard calls it, being another. And so it's really if you look at this from this way, it's just two different ways of achieving the same thing. And I personally, and also from what I've been referring to it from the standard, really see that in the way that there's no tokenization versus formal preserving encryption, but there's tokenization and then there's the various forms of doing tokenization. So it's not like one is better than the other, but it's just different ways of achieving the same thing in the end.
Excellent. Thank you, Henning. Okay, so I do not see any other questions line up. So I think then it's time to wrap this webinar up. Thank you, everyone in the audience for attending. As I said, a recording to this webinar will be sent out in the next couple of days. And until then, I wish you a wonderful rest of the day.